Climate change is leading to a rise in sea levels.
Big story tonight is the beginning of a rainy stretch and a swarm of earthquakes in the East Bay. And they all hit within a few minutes of each other in the 7 o'clock hour.
Well, a strong red tide bloom is causing problems along the Texas coast, killing sea life and even making it hard for beachgoers to breathe.
Texas, famous for its sprawling deserts, roaring cattle drives, and legendary oil booms, holds far more beneath its surface than meets the eye. From the wind-whipped plains of the Panhandle to the shimmering Gulf Coast, the ground below Texas is restless with secrets. Most people see Texas as a land defined by its size, its spirit, and the endless horizon. But lately, the real stories have begun to rise from deep below. It started subtly, minor tremors, a shiver in the bedrock. Then a wave of discoveries surfaced and left scientists astounded. In recent times, teams from Texas have uncovered distant galaxies, made advances in invisibility technology, and perhaps most astonishingly, uncovered fresh geological mysteries beneath their own homeland. This vast state's grandeur has always been legendary, but the enigmas hidden within its borders stretch far beyond what any oil rig or cowboy tale can describe. Picture teams of researchers poring over seismic records, seeing variations in the Earth that don't fit traditional models. Imagine waves meeting stretches of coastline that have changed almost overnight, or the quiet rumble of the ground as new secrets push toward the surface. Now scientists gather at instruments that deliver unexpected readings, revealing clues that Texas's foundation is anything but ordinary. In this video, we're plunging beneath Texas's iconic landscape to reveal earth-shaking discoveries, each stranger and more consequential than the last. From awakening volcanoes to ancient life forms older than the dinosaurs, prepare to witness the Lone Star State as you never have before. Curious about just how wild and mysterious Texas geology can get? Hit that like button, subscribe for a front row seat to the latest in Earth's untold stories, and join our journey straight into the unknown. Ready to step beneath the surface? Let's begin. Volcanic unrest rocks Texas plains. Sudden rumblings echo across West Texas. Could Texas harbor a volcano ready to wake from its ancient slumber? Many imagine Texas as a bedrock fortress, land so steady that earthquakes are a distant worry. Yet beneath the Davis Mountains, seismic stations near Mara and Alpine have detected curious low-frequency tremors far beneath the normal range for earthquakes, over 200 in the last year alone. Seismologists from the University of Texas at Austin were first to notice seismic swarms that don't align with standard fault lines, instead clustering around ancient volcanic features. The Davis Mountains themselves are remnants of volcanic activity dating back 36 million years. However, these new tremors hint at deep crustal movements, perhaps even magma shifting beneath great pressure. Does this mean Texas could face a volcanic eruption? Scientists stress that no eruption looms on the immediate horizon. Still, geophysical models show signs of rapid heating in a zone nearly 12 miles down, and trace gases like sulfur dioxide and helium isotopes have increased in remote springs, a hint of magmatic gases creeping upward. While an eruption remains highly unlikely for now, these signs reveal that Texas's volcanoes aren't as extinct as once presumed. If the ground's rumblings intensify, what else might lie waiting to be discovered in the heart of the West Texas desert? Gargantuan void beneath North America. Could Texas be sitting atop one of the continent's biggest underground mysteries? Stretching from Texas Hill Country toward Oklahoma, geologists have identified hints of a vast geological anomaly. While Texas is known for enormous cave systems, such as the caverns of Sonora or natural bridge caverns, what's been indicated is an area of low seismic velocity deep beneath the bedrock, suggesting a region with less density than the surrounding rock, possibly created by ancient geological processes.
Scientists at Southern Methodist University used seismic imaging to map a shadow zone where waves slowed and scattered, evocative of past dissolutions or geologic stretching. This area beneath the rolling limestone outside San Antonio and into Oklahoma may have been shaped by a mixture of past groundwater erosion, ancient rifting, or the migration of fluids. Is this underground void as vast as legends suggest? Most experts believe it is unlikely to be an empty cavern, but rather a region where rock is fractured or less consolidated by geologic activity. However, such weaknesses might explain why sinkholes or odd patterns of ground subsidence have appeared in places like North Texas. Could this zone shift or collapse, triggering more significant ground movement? While catastrophic collapse is improbable, ongoing monitoring is in place and the geological curiosity remains, a reminder that the bedrock beneath Texas's grasslands hasn't yet revealed all its stories. Newborn islands rise in the Gulf. Could Texas waters be giving birth to entirely new land right before our eyes? It sounds fantastic, but over recent years, the Texas Gulf Coast has witnessed rapid changes in its sandbars and barrier islands, especially after major storms. Satellite imagery and coastal monitoring have captured small islets and sandbars forming off places like the Laguna Madre, one of the world's longest barrier islands. Coastal geologists like Dr. Susan Havula from the University of Texas at Austin have documented these shifts driven by a combination of powerful storms, persistent ocean currents, and rising sea levels. Sometimes what appears as open water can transform into new land over a season, especially after hurricanes redistribute tens of millions of tons of sand and silt. Are these true volcanic islands? No volcanic activity has been identified off Texas's coast. Instead, these features owe their existence to sedimentary deposition and storm-driven rearrangement. Occasionally, magnetic minerals can be concentrated by water movement, distorting compasses, rare but possible in heavy mineral pockets. These newly formed landforms show how Texas's coast is continually reshaped, a living boundary where sea and sand are in constant dialogue. But if islands can appear and vanish so quickly, what else could these lively waters reveal about the forces at work beneath the Gulf? Submarine eruptions threaten the coast. What really happens beneath the waves off Texas's coast? Last spring, reports spread among fishers and boaters of large methane bubbles and odd burbling off Corpus Christi. The U.S. Geological Survey and local marine scientists investigated, confirming the presence of gas seeps offshore. These aren't volcanic eruptions in the fiery sense, but rather releases of natural gas and geothermal fluids from the seafloor, often after storms or as new cracks open along the seabed. Texas's portion of the Gulf is dotted with oil and gas leaks, some natural and others influenced by human development. The underwater landscape remains active. Seafloor mapping has charted domes and pockmarks where gas occasionally forces its way up, sometimes with enough pressure to disturb fish and surface waters, but not to erupt volcanically. The main risks are environmental. Sudden gas releases can cause fish kills or even small-scale mudslides on the shelf. While not a threat on a catastrophic volcanic scale, these submarine gas seeps highlight the unstable nature of the Gulf's underbelly, a zone shaped by the interplay of natural hydrocarbon reservoirs, shifting sediments, and the persistent hand of storms. Ancient microbes from lost worlds. Can life from Earth's deep past still thrive beneath Texas? While geologists mapped ground tremors, Texas A&M researchers have drilled into underwater sediments and blue holes along the Gulf Coast, searching for unusual life forms. Their efforts have yielded colonies of extremophile microbes, organisms that process sulfur or heavy metals and survive without sunlight in high-pressure and mineral-rich environments. Some DNA sequences from these forms are unlike known surface organisms. These microbes are likely relics of ancient biospheres, possibly with ancestry predating complex animal life. These extremophiles offer windows into Earth's earliest biology and may carry clues for how life could survive on other planets. Their study could reveal new medicines, enzymes, or other applications beneficial to humans. Are these life forms a danger? Most researchers are cautious but optimistic. Ancient or deep-dwelling microbes rarely pose a threat to modern ecosystems, but as with any discovery from extreme environments, careful assessment is a must. For now, their mystery lies in what they might teach us. Cryococcus ripple across Texas. Could shifts in Texas's climate be the invisible hand behind so many of these Earth changes? Dr. Michael Young at the University of Texas Bureau of Economic Geology has studied the interplay of climate and geology across the state. Increasingly erratic rainfall driven by changing climate patterns scour riverbeds and accelerate erosion, sometimes unearthing ancient fossils and reshaping the land with each passing season. Along the coast, warming waters amplify storm impacts, while inland, reports of ground subsidence and shifts in creek flow have coincided with drought and heat patterns. The connection between weather extremes and geological responses is now a focus for Texas scientists, as droughts cause sinkholes to appear, permafrost to thin, and sediment to move at unprecedented rates. Even
The slow rebound of rock after erosion, or fluid movement deep in the crust. In regions like the Waco Mountains and the Permian Basin, this uplift aligns with subtle magnetic anomalies, zones where heat flow may be greater, though evidence for recent magma movement is limited. Residents in some towns have noted subtle tilts or cracks, often linked to the Earth's slow and continual reshaping. Scientists continue to monitor these changes, seeking to connect surface shifts with deeper geophysical processes. Is new mountain building in Texas's future? That's unlikely, though ongoing uplift is a stark reminder that Texas sits atop a living, moving geologic foundation. Volcanoes' hidden heart. Is there a supervolcano sleeping silently beneath Texas? Much of West Texas, including the Glass Mountains, bears the scars of ancient volcanic events. Large magma chambers formed during these distant eras. But today's data, gathered from seismic instruments and surface uplift measurements, suggests deep reservoirs are long since cooled and solidified. Although surface deformation is ongoing, there's no evidence of a current Texas-based supervolcano or a magma chamber with the explosive potential of sites like Yellowstone. What has been detected are smaller, isolated zones of warm rock left from past activity. The focus is now on continued monitoring of seismic patterns and ground deformation to ensure that any unusual changes, however subtle, are identified early. How close are we to understanding the hidden threats beneath Texas? Much remains to be studied, but as of now, experts agree a supervolcano eruption is not considered a present danger. And mantle plume anomalies. Are there channels of molten rock creeping up beneath Texas? Geophysicists, using electromagnetic imaging, borehole drilling, and seismic records, have traced hot, less dense rock beneath regions west of Abilene and near Big Bend. These anomalies may represent ancient weaknesses where heat has moved from deep in the earth, or old scars left by inland seas and tectonic collisions. While mantle plumes, the forces that drive eruptions in places like Hawaii, are not confirmed under Texas, areas of elevated heat flow and crustal thinning have been identified. The most plausible explanation is that Texas's geology is influenced by a patchwork of ancient processes, old seas, past volcanic pulses, and shifting plates at North America's edge. Could further study reveal new hotspots? It's possible, but as of today, Texas's main geologic challenges involve slow deformation and legacy reservoirs of heat rather than major upwelling plumes.
C4 spreading, and fault lines. Is new land being created beneath the Gulf of Texas? The Gulf of Mexico is underlain by complex geology shaped by ancient C4 spreading. But active spreading ridges like those in the Atlantic or Pacific are not found here. Subtle fault lines run offshore, and fresh sediments do pile up, but not through the birth of new volcanic crust. Occasionally, sonar scans reveal new silt ridges and subaqueous hills formed by sediment movement rather than molten rock. Onshore, the slow rejuvenation of old faults can sometimes trigger unexpected quakes. Small, but always worth watching. Have new fault networks appeared? Not recently, but ongoing monitoring ensures that shifts are detected early, reminding us that Texas, though not California, still sits on a living piece of the continent. Viruses. Could thawing ground or shifting rivers unearth ancient life? As Texas's rivers cut new channels and reveal layers of sediment, occasional finds of fossils, petrified wood, and even ancient pollen remind us that the state was once covered by tropical seas and lush forests. Sediment cores from riverbeds have yielded dormant microbial life and rare genetic traces, though truly ancient viruses awakening to threaten modern ecosystems remains unproven speculation. There's no current evidence of ancient pathogens infecting Texas wildlife or people. However, as climate change exposes new layers, there's always scientific interest in studying what emerges, both for understanding Earth's history and for its potential impacts, positive or negative. Alongside these finds, minerals and hydrocarbons sometimes appear, fueling discovery and the perpetual balancing act between resource extraction and environmental caution. Fading lakes, dying rivers, and reborn rainforests. What happens when water vanishes and land is reborn? Central and western Texas have seen lakes and river stretches shrink due to drought, water diversions, and in rare cases, ground shifts from subsidence. When water recedes, ancient forests or previously submerged land can briefly emerge, as noted when reservoirs reveal stumps or old tree groves after periods of low water. Satellite imagery has captured these cycles, with new vegetation springing up along drying riverbeds, inviting new birds and wildlife. Yet the transformation isn't always benign. Faltered riverbanks and regions of subsidence can disrupt towns, highways, and agriculture when the ground shifts beneath them. On the coast, strong storms and flooding alter the land in dramatic, sometimes damaging ways. Texas's weather cycles, powered by the Gulf and shaped by global climate, drive both destruction and renewal. The only constant is change itself. As summer storms gather over the Gulf and seismic sensors watch the desert, Texas stands at a crossroads. Under our feet, geologic worlds are stirring, voids shifting, ancient microbes surviving, land being reformed in cycles of loss and rebirth. The landscapes we thought we knew are always changing, shaped by deep forces and the restless energy beneath. Which of these Texas geological mysteries do you find most astonishing? Is it the possibility of ancient volcanoes, emerging islands, or life forms invisible to the eye? Let us know in the comments. And if you hunger for more wild Earth discoveries, don't forget to like, subscribe, and turn on notifications. Until our next journey, stay curious and keep exploring. The surface hides more than you think, especially in amazing discoveries. Make sure to subscribe and hit the bell icon. Share this video with friends and join the discussion on what these findings could mean. Your thoughts and questions are important, so let's explore incredible mysteries together.